Okay, everybody, welcome back. Mr. Willis here, and I'm going to kind of go into a little detail about the material we're going to be covering this week, which is going to be layers of the Earth. I got this nice, pretty picture that I got off the internet. Obviously, I didn't draw this, so we're going to talk about this in some great detail today. But we're also going to take a look at and just go over a couple of little things and questions that had popped up over the last week. So you guys have been doing a good job. I've had some good turn-ins for the materials that have been taking place so far. So keep doing the work. And for those of you who haven't done the work, go back and work on the earlier assignments and kind of build your way up to this. Make sure you're taking care of those things. Make sure you're sending me any messages you have through Google Classroom if you have those, and I'll try to get back to you as quickly as I can. So just to kind of reiterate, the classroom code is up here. If you guys have some friends who are not in the class, certainly send them the code, encourage them to get on, because obviously, look, guys, the bottom line here is I want you guys to be as prepared as you possibly can be for next year. And with this big gap, I don't want you guys to have to suffer through anything next year. So make sure you're doing the work. It's here to help. I'm trying to keep it, to a minimum of what I can keep it to. But I want you guys to do something, right? Because this huge gap in between now and whenever ninth grade is going to start for you guys, I don't want you to have lost what was a good year. We were doing a really good job up to this point. So keep doing what you're doing. Those of you who are turning your stuff in, thank you. I appreciate it. Ignore the lightning and thunder in the background. I'm videoing this during some interesting weather right here. So we have that. Also, if you're having some problems getting onto the Google Classroom, you can go to the Homa Junior High website. You can go over to the faculty page. You can find Mr. Willis down here, and you click on this, and it's going to have all the login information for FOSS. It's going to have the Google Classroom log information. It's got my school email address if your parents need to contact me. And on the important date tab, it's going to have the assignment for the week. So the way that I'm going to break up this week's assignment, and I haven't posted it on here yet, is it's going to have three parts: a Monday, Wednesday, Friday part, and there's going to be about an hour or so of work, I would assume, for each of those days where you can kind of work on it through your own pace, and for those particular things. So the general outline is Monday you'll have the video, this little video for me. You're going to have the series of notes, which I'm going to have for you right here. I'm going to talk to them, go through them, and do some little diagramming on the computer so you guys understand the topic. On Wednesday, I found a really neat little Khan Academy video for the same material. I'll let you guys listen to somebody else besides me, in the hopes that any questions would get clarified between those particular things. And there's going to be a little web quest where you guys are going to go searching around for some information on a specific topic for me. And then on Friday, I'm going to have a little review, constructed response, critical thinking type question thing, which is going to go back for the past couple of weeks and have you guys look through all that material. You can obviously use your notes. You can use your FOSS notebook. You can use whatever websites you want to use. Use the internet. Use the resources that you guys have at your disposal. It's just, again, a way to us to tie everything in together. And then next week, what I'll do is I'll put a little video together answering those questions for me. So you can go back and take a look at your work and kind of see where you're at. And if you have any questions, you can then relate those to me through the Google Classroom. All right, so let's go ahead and hit the ground running because I don't want this to be a 15-minute video again. All right, so back to the images here. All right, so we're going to talk about the layers of the Earth here. And I think most of you are pretty good with this. I think you understand what's going on as far as the general things are going here. Let me find a color that's useful. Yeah, yellow works. All right, so the idea here is that we're trying to just discuss the general chemical layers of the Earth and the mechanical layers of the Earth. And what I mean by that is the layers of the Earth, some of them have some extreme differences in composition. And some of them are going to be incredibly similar in composition. They're just going to have some mechanical differences. Things like one's going to be a liquid, one's going to be a solid. So it's going to be important for us to kind of understand that. This is not drawn to scale, even though it says drawn to scale here. The crust that we have here on this outer layer, the outer shell of the Earth right here, has got two parts. It's got the oceanic crust. It's got the continental crust that we see in those particular areas. And that's going to be something that we can see in those particular areas. So that's something that we have that we're familiar with, obviously, because we live on it. It's between 30 and 50, 30 and 60 kilometers thick. It's obviously thinner over the oceans and thicker over the crust, and that just kind of makes sense based on the landform types that we see in those particular areas. The crust is made primarily a huge amount of silicon and oxygen are going to probably be the two most common elements that we find in the crust. And we find large amounts of those materials in both basalt and in granite, which are going to be two of the really common igneous rocks that we find on the Earth's surface. Lots of common rocks. Obviously, this is where the rock cycle is really taking place. We're seeing all three families of rock here: the igneous, the sedimentary, the metamorphic rock. And those rocks are created and changed based on where they're located on the Earth, what geologic processes are close to them, what atmospheric processes are taking place. Because obviously, erosion and weathering are going to play a huge role in the creation of sedimentary rock, which is obviously important because of the fossils that we have there. So we have that. So the crust is the thinnest layer of the Earth, right? Between 30 and 60 kilometers. There are some spots on Earth's surface where we think the crust is between 5 and 7 kilometers thick. So that's only a couple of miles. So it's really important to understand that we're living right on the top of that eggshell that exists on the outer part of the Earth. At the bottom of the crust, there's a layer of material that is connected to the mantle. It's glued in this particular area here. And that layer is called the lithosphere. The lithosphere is the welded part of the upper mantle, which is significantly thicker. We're talking about 3,000 kilometers or so for the mantle. And excuse my writing. I'm writing with the mouse here, guys. So 3,000 kilometers as opposed to, say, 30 kilometers, right? So we're looking a huge difference in scale between these two. But the upper part of the mantle is kind of welded to the crust, and that's going to be the part, that's what the plates are made from, and those are going to be those big pieces of lithospheric movement that we're going to see at the surface, which is going to be important because that's what we're going to see moving around on the Earth, right? So let me get rid of my little thing here. You guys can see I've gotten a little more used to using the internet version of this, and I'm going to attach this KMZ file to the Google Classroom so you guys can play around with it to take a look at the plates that exist on the Earth. But these big chunks of crust are welded to the top of the mantle. And then there's some interesting little areas. Hawaii was that spot that we talked about as a hot spot. This crustal plate here gets burned through because of the incredible temperatures at the bottom of the mantle. So that's why we see this hot spot volcano here. But we can see all of these plates, and I know it's a little hard for you guys to see here, but you can see the arrows that have been added to show you the direction of the plate movement here. So I wanted to make sure all that information was as up to date and correct for you guys as you can get. You can see this transform boundary that we see here. But all of this, again, is caused by the movement of material in the mantle. All right, so let's get back to the image here. And so the mantle is going to have these huge plumes of material that are going to move, and they're going to move incredibly slowly. So we normally classify the mantle as a, well, let me see if I can actually find the pin here. Here we go. That's a line. Cursor visible. All right, bear with me, guys. I'm still trying to get used to using this thing. That is definitely not it. All right. Oh, there we go. All right. Oh, nope, that's an eraser. All right, back to the line. All right, so we've got this here. So we've got material tends to want to move upwards, right? Heat wants to move outwards because the material is less dense, and less dense is going to cause the more dense layer, the cooler layer, to move back down to the bottom. So we're going to get these huge circular convection currents that are going to occur in the mantle here, right? So you're going to get these looping currents that occur, and they're going to be moving material around. And where these currents hit the asthenosphere and then the lithosphere located above that are going to be the areas where we see the Earth's surface crack. And those cracks are going to be the areas where the material is getting moved around. So new crust gets created right here. This was located right in the middle of the Atlantic plate at the mid-ocean ridge, and that forces the two continents to move apart. So this is all caused by the heat on the inside of the Earth that's trying to escape, right? So again, think of a cake. You leave it in the oven too long, it starts to crack in the middle because that liquid material, the cake dough or whatever you want to call it, cake batter, I guess is a better word for it, is liquidy, and it's moving in these circular currents. And as it starts to solidify, as they get less pressure at the top, it starts to reharden and become that solid. It pulls apart because that's just what heat's going to cause these things to do. So the mantle is made of a couple of kind of layers. There's the top layer, which is called the lithosphere. There's the asthenosphere that we have located right here. And then there's the mesosphere, which is located right down at the bottom of the mantle here. This is going to be where we got some weird transitions and things that are going on. So this is going to be made primarily of rocks. There's going to be a lot of iron. There's going to be a lot of magnesium. There's going to be some silicates that are located there. And that's going to be kind of important. So the rocky layer of our planet is really from the mantle boundary up to the surface. Okay, and that's going to be important for us to understand. So as we go down through the layers of the Earth, pressure increases, temperature increases, and density increases. And that's going to be really important because that's going to affect the behavior of these things as we move forward. All right, so when we get, okay, and again, guys, you hopefully are following along on the little note page that I have here. So this is the material that I've been talking about. Let me clear that out. So we've got the crust. We've got the two types of crust, and I've mentioned these in a previous video, so I'm not going to go into it in a lot of detail. Oceanic crust tends to be thicker but more dense than the continental crust, and so thinner, more dense, I apologize, thicker, less dense for the continental crust, and that's going to be important. The mantle, again, that chemical composition, lots of iron, lots of magnesium. It's going to be about 3,000 kilometers thick, and there's going to be multiple layers inside of that. And you know the materials that I'm giving to you here will help you with that. So we've got the lithosphere at the top, the asthenosphere, and then the mesosphere down, which is at the bottom. All right, now getting to the core. All right, so the core here, you can see I don't have a huge amount of notes, but we'll zip back to the little diagram that we have here. The core is going to be about 3,500 kilometers all together, right? So you're going to be looking at a pretty large outer core and a relatively smaller inner core, probably about a third of the size. Now, the important thing to recognize is both of these layers, and get the pen back on here, both of these layers, right? So the outer core, this is just not working for me today, guys. All right, so the outer core and the liquid core are made of the same stuff. All right, so chemically, we're talking about the same things. Iron and nickel. We think metals are going to be primarily the things that are located here. And that kind of makes sense if you understand how we think the Earth was originally formed. Whenever the collisions were going into the planetary formation early in Earth's history, the entire planet was probably a liquid. And when you have a liquid, where does the heavier stuff tend to go? It tends to sink down from the surface towards the middle. So what you're going to get is the heavier metals that make up the Earth just in general, while the Earth is in its liquid state, are going to sink all the way down to the core. And then they're going to get pulled there by what force? Gravity, right? And then the lighter material, the silicates, the oxygens, the gases, the carbon dioxide, all of those things are going to bubble up, kind of like the bubbles from the bottom of a soda can, right? So that's going to be really important for us to recognize. But the inner core and the outer core are made from iron, right? So iron and nickel, all right, which is going to be the two elements that we find on the periodic table here. Now, again, we haven't been down there to take a physical sample of this, but what we can do is we can track seismic waves that occur on the Earth's surface. So if there's an earthquake, probably more accurately like over here in Mexico, that's going to cause waves to travel through the entire planet. And we know that waves speed up and slow down when they go into different types of materials. So we track how fast those waves go through using a seismic network that we have all over the planet. And from that, and the data that we collect from these earthquakes that occur at the Earth's surface, we can extrapolate and try to figure out what type of materials are on the inside of the Earth, where the transitions occur, what's causing those to bend. So you guys should remember refraction. Whenever a wave goes from one medium into another medium, it's going to bend. So those are all things that geophysicists use to try to figure out what's going on at the bottom of these layers. All right, so we've got the so the two layers. We've got the liquid outer core, the solid inner core, both made primarily of iron and nickel. So it's about 2,300 kilometers for the outer core, about 1,200 kilometers or so for the inner core. And remember, there's not like a line. There's not a sign down there that says "Welcome to the outer core." It's where these transitions have occurred, and we've went to a true liquid like we would associate, right? It's going to have a pretty low viscosity. It's going to move fairly easily. We're going to have that. The mantle is kind of weird. It's a solid, but it's a movable solid. So it's kind of like it's kind of like old Play-Doh, where you got some give to it. It can move based on pressure and whatever forces are acting on it. And hopefully at this point you're understanding that the forces that are acting on this are going to be heat, right? And these convection currents that are occurring in the mantle. All right, so what's kind of the big ideas I want you guys to get from this using this little here, and I'm going to attach this to the Google Classroom as well, is that as we go down, as we go through the material that is located here, as we go through this, didn't get the pen again. All right, so back to this. So as we go down from the surface, down towards the core, pressure increases, temperature increases, density increases, and there's going to be some chemical changes. So we've got lots of silicon and oxygen at the crust. In the mantle, we've got lots of iron, or at least lots more iron at the bottom, lots of magnesium, lots of silicon. We're going to have some of those lighter elements at the top, and some of those metals are going to start to congregate down near the bottom, we think. And then once we get to the core, we're almost talking about entirely metal. So iron and nickel, plus a bunch of radioactive isotopes that we think are contributing to the heat that the interior of our planet has, right? So the interior temperature of the Earth is hypothesized to be hot, right? 6,000 degrees Fahrenheit, which is plenty hot enough to keep these metals in their liquid state. But what's interesting is, because the pressure is so high in the inner core, these materials here in the inner core, the pressure causes them to get locked in place. They're physically, the particles, even though they want to move, remember, whenever we talked about liquids as a state of matter, is the particles can move freely. There is so much pressure, these particles can no longer move freely, and if you can't move freely, you don't have a liquid anymore. You have a solid. So that's going to be really important. All right, so you guys need to remember and understand the chemical composition of those layers, right? So the crust, the mantle, the core, and then the structure of the earth in general, right? That's going to be important. So let me get back to the notes here so you guys can take a look at that. Whoops. All right, so back here. So we've got, as we progress from the core, we got temperature increasing, pressure increasing, density increasing, and then the chemical composition of the earth changes. So we've got three big parent layers, the crust, the mantle, and the core. So the crust is made of the continental crust and the oceanic crust. The mantle is made of the lithosphere, the asthenosphere, and the mesosphere. All of this is located in the notes for you. And then the core is made from the liquid outer layer, which is the outer core, and then the solid inner layer, which is the inner core. So chemically, all of these are the same, right? So all three layers of the mantle are similar. All two layers of the crust, the continental crust and the oceanic crust, are very similar. And then obviously the core we think is the same two types of metals primarily. So I've got a little link here for the structure of the earth in general, which is going to bring you to a little Wikipedia page that you can take a look at if you need some more clarity. Now, when we look at physical characteristics, physical properties, remember those are things that we can see or we can infer based on evidence. These are going to be the layers of the earth. We've got the lithosphere, which is the top part of the mantle, and the crust that are stuck together. This is basically going to be your plates. Let's see if I can spell that right. Still can't spell it right. So these are going to be the plates that make up the top of the Earth's surface itself. The asthenosphere is going to be kind of this outer Play-Doh, old kind of Play-Doh layer that the crust and the lithosphere sits on. It's going to be the thing that's moving around, and it's welded to the lithosphere. And since it's welded to the lithosphere, it's going to move. When the asthenosphere moves, the lithosphere moves. So this is where we get the plate movement on the surface of the Earth. The mesosphere is going to be this layer where we got these transitions going on between it's a big layer, but it's where we're going to see the materials start to change properties as they get closer and closer to that metal outer core that we see here. And then again, the outer core and the inner core, the outer core is a liquid. The inner core is a solid. That's going to be the things that we have here. Down at the bottom here, what I did was a little bit different than the last one, because I don't know if you guys are actually doing the vocabulary, is I made a little matching thing here. You guys can draw some lines on this or highlight it or put some letters next to this so you can kind of get the vocabulary words here. So your vocabulary words are on the left, the definitions are over here on the right, and you can use the internet, you can use your FOSS notebooks, you can use any of those resources. I want you guys to kind of tie these together. So subduction, convection currents, Pangea, we've all talked about. Plates, we've talked about. Panthalassa, I mentioned while we were in class, but you guys may have forgotten it. Magma, we've talked about. Continental drift, mid-ocean ridge. Laurasia is another word that I talked about in reference to continents breaking up from Pangea. And then trenches. So you guys can go back and look at those other videos if you like for those particular things. All right, so we have that. So that's kind of where we're at so far on these particular things. So what I'm going to be assigning to you guys over the next couple of days is going to be a little quiz to complete when you're done with this video. It's a problematic quiz, very similar to the ones that I've been handing to you guys so far through the little thing that we've been working on. On Wednesday, I'm going to have a little web quest for you guys where you can go on the internet and you can kind of search for some answers. It's going to talk about pressure. It's going to talk about the individual physical differences between those layers so you guys can get that kind of more together in your head. And then lastly, on Friday, I'm going to give you guys a little review, which is going to have six of them. Actually, I'm looking at it right now. Constructed response questions that I want you guys to put some effort into. I want you guys to go through this, use the notes over the last couple of weeks, use the videos, and I want you to answer it. You can answer it right on my document. It doesn't have to be an essay form, but I'm looking for good answers to show that you guys got some mastery of this material. So if you have any questions, please feel free to shoot me a message. I try to check it a couple of times a day so I can do that. And on that note, it's good to kind of be talking about science again. So thanks for listening to me. I certainly appreciate it. I hope everything's going okay for you guys. I hope you're learning some stuff because this takes some effort to put these things together. So hopefully you're learning this material. Hopefully it gives you an opportunity to learn this stuff as we move forward. And hopefully you got an opportunity to use some things that you haven't had the opportunity to use before. So this Google Earth platform is fantastic if you want to get an opportunity to use that and do this. And again, I will have the KMZ file that you guys can input into here so you can see the plate boundaries. So Take care. I miss you guys. Hopefully everything's going well. If you've got some questions, send me a message. So that's about it. Thanks. You guys have a good day. Talk to you later. Bye-bye.